All right, mutually exclusive and non-mutually exclusive events. Mutually exclusive events are basically events that have different attributes that cannot occur simultaneously. Examples include flipping a coin, heads or tails, picking a card, club, diamond, heart, spade. So those two have different events that cannot occur simultaneously. Additive principle, the rule of sum for mutually exclusive events, is the probability of either of two mutually exclusive events, A or B, is the probability of getting A or B is taking the probability of A and adding the probability of B. Now, instead of the word or, we tend to use the U symbol to indicate or, and that's what the book uses. So remember, the U symbol means or, and we will be looking at and as well, and is an upside down U. So this is the or symbol, and probability of A or B is equal to the probability of A plus the probability of B. Let's try an example. Example 1. A coin contains the following juice bottles. A cooler contains the following juice bottles. 3 orange, 5 apple, 3 citrus blend, and 4 grape. What is the probability of reaching in and randomly choosing an orange or a citrus blend? Show your answer using a Venn diagram and the additive principle. So let's try and do this. So to use a Venn diagram, what we do is we have the sample space inside the Venn diagram. So 3 orange is what we want. We have 5 apple, which we will have in a second. 5 apple, there we go. 3 citrus blend, which is what we do want, and 3 grape, which we don't want. So to get the answer to this, the probability of getting an orange or a citrus blend is to take the probability of an orange plus the probability of the citrus blend, and that will tell us what our probability is of getting orange or citrus. So 5 A's, 4 G's, 3 C's, 3 O's. So the probability of getting orange or citrus is as follows. Well, we have 3 out of a total of 15 plus 3 out of a total of 15. That is 3 out of 15 to get orange, 3 out of 15 to get citrus, which gives us a total of 6 out of 15, which reduces itself to 2 out of 5. Now you could have simplified this first and then got 2 out of 5, or you could add them first and then simplify. Ultimately, your final answer will be 2/5. The probability of getting orange or citrus is 2/5, or if you want to convert it to a percentage, it would be 40%, or 0.4 chance of getting orange or citrus. Next, non-mutually exclusive events are different events that can happen at the same time. An example is determine the probability of picking a diamond or a face card. So we're going to go through the list of cards here just so that you have them. These are all the possible cards. So you understand there are 52 cards altogether. And with these 52 cards, what we have to do is calculate the probability of picking a diamond or a face card. So let's identify all the diamond cards. Here we go. The diamonds are all here. And now we want to identify all the face cards. So identify the face cards by highlighting in green. That would be Jack, Queen, King, going all the way down. And notice that this is doubled. You have, not only can you have a diamond, but you could have a diamond face card. So the probability of picking a diamond or a face card, when we calculate it here, it looks like we have a double set. Well, not really. I want you to understand, to calculate the probability of getting a diamond, a diamond is 13 out of 52. A face card is going to be 12 out of 52. There we go. There are 12 face cards. There are 13 diamonds. Now, to calculate the probability of a diamond or a face card has to have some calculations involved. That is, probability of the diamond plus the probability of a face card minus what? Well, we're going to minus the doubles. The doubles, there were 3 that were doubled. Do you notice? Do you see here? They were counted twice. We need to take one of those out. So 3 out of 52 is taken out because it was doubled. Because those are the diamond and face cards. Okay, diamond and face, which were doubled. When we do that, we find out that the answer to this is 22 out of 52, which is 11 out of 26. So the probability of diamond or face is 11 out of 26. All right, next one. The counting strategy used in example 2 is known as the principle of inclusion and exclusion. So we have A and we have a set B, and then in the middle we have A and B. What does that mean? Well, the principle of inclusion and exclusion is as follows. If A and B are non-mutually exclusive events, then the total number of favorable outcomes is the number of A or B, which is equal to the number of A plus the number of B minus what was counted double. So notice that A and B has a certain number in B, has a certain number in A, but the number that was doubled is the A and B, the stuff that fits in both parts. So you must subtract the number of A and B in order for this problem to work. So, probability of non-mutually exclusive events is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B occurring. So again, remember that N means the number of possible outcomes, and P would stand for the probability of possible outcomes. Moving forwards. Example number 3. Sophia is part of a gift card Secret Santa. Of the 32 participants, 16 prefer Starbucks, 10 prefer Tim Hortons, and 8 prefer Starbucks and Tim Hortons. If Sophia draws a name, how many prefer Starbucks or Tim Hortons? All right, now, what is the probability that she will pick someone who prefers Starbucks or Tim Hortons? So we need to know whether they chose, how many would choose Starbucks, which is 16, how many would choose Tim Hortons, which is 10, and then also how many would choose Starbucks and Tim's, which is 8. So 16 would choose Starbucks, 10 would choose Tim's, and 8 would choose Starbucks and Tim's. So the number of Starbucks or Tim's is going to be 16 for Starbucks, 10 for Tim's, minus 8 that preferred both. And that gave you 18. That's the number. Now, what's the total number of participants? Well, Starbucks or Tim's is going to be 18, which we already calculated. Remember, it's 16 plus 10 minus 8 over 32. Why? Because there are 32 participants in total. Okay, now some of you are going, but why did we do this? Why did we take out the 8? I want you to understand how this question works. This is Starbucks, so there's 16 that prefer Starbucks. 10 prefer Tim's. 8 prefer Starbucks and Tim's. 8 of the Tim's people prefer Starbucks and Tim's, and 8 of the Starbucks people prefer Tim's. We can't have 8 counted twice. So when we do this, we take 16 plus the 10 minus the 8 that prefer both, because remember, they raised their hand for Starbucks, they raised their hand for Tim's, and we found out that people counted themselves twice. So we have to subtract one of those times that they were counted, and that gave us 18. 18 out of the 32 prefer Starbucks or Tim's, and that's 9 out of 16. 9/16 chance of getting someone who prefers Starbucks or Tim's. Moving forwards. Example number 4. Determine the probability of randomly picking a character that is human or one that can cast spells. The characters are, alright, and let's go look at all these characters. Here they are. Dragon, hawk, knight, lion, wizard, witch, unicorn, princess. And we need to go through these. So, the characteristics we could have are supernatural, animal, flies, human, cast spells, and that's it. So those are the different characteristics. We want the characteristics that are human or one that can cast spells. Okay, so human human are these ones. And so knight, wizard, and witch are all human. Now, and princess, knight, wizard, witch, princess are human. The ones that can cast spells are wizard and witch. So we have the probability of human or cast spells is equal to 4 human out of a total of 8, and plus 2 that can cast spells out of 8, which equals, minus 2 out of 8, that's doubled. Remember, we counted these twice. So 4 out of 8 plus 2 out of 8 minus 2 out of 8 gives us 4 out of 8. So you have a half a possibility of choosing either a human or one that can cast the spells. You have a 50-50 chance. Okay. Now note, again, there are many characteristics. There's supernatural, animal, that flies. So that's 3 characteristics here. There's 2 characteristics here, 1 here, 1 here, 3 here, 1, 2, 3, 4 here, 2 here, and 1 here. So there are many different characteristics. So we have to go through the characteristics of each to answer the question. Example 5. Mrs. Merrick this is goodness me. Let's go through this really slowly, folks, so that you have all of these. This is a lot here. So let's focus on each one of these questions. Okay. Here we go. Mrs. Merrick puts the letters mathematics into a paper bag. If Mrs. Merrick reaches into the bag and randomly takes out one tile, determine the probability of each occurring. She chooses either an M or a T. All right, how many M's? So we were doing M or T. Probability of M or T is going to be M. How many M's are there? 1, 2. 2 out of a total of 11 plus 2 T's out of a total of 11. So 2 out of 11 plus 2 out of 11 gives you 4 out of 11. So this is the probability of myself choosing an M or a T. Part 2. She chooses a red letter or an A. Well, a red letter or an A. So let's do the A first. What's the probability of getting an A? Well, there's 1, 2 out of 11. what's the chances of me getting a red letter? Well, there's 1, 2, 3, 4. 4 out of 11. Notice something? That's right. You should have noticed that A is also, there's one of the A's that's red. So we not only counted it as an A, but we also counted it as a red letter. So we have to subtract 1 out of 11. That is what's been counted twice. So 2/4 plus 2 elevenths plus 4 elevenths minus 1 elevenths will give you 5/11. Now let's do part 3 down below. Part 3 says chooses a consonant or a black letter. So a consonant is not the vowels. So consonant or a black letter. So let's go through the consonants. The consonants are going to be 7/11 because this is a consonant. 1, 2, 3, 4, 5, 6, 7. Those are the consonants. All right, 7 out of 11 plus the black letters. There's 1, 2, 3, 4. 4 black letters. Did we double count anyone? Well, yes. This one is a consonant and a black letter. Any others? Yes. H is a consonant and a black letter. C is a consonant and a black letter. So we have to subtract 3 out of the 11. A result will be 8/11. Now, part 4. She does not choose a blue letter or an M. How would we approach this question? Well, what we'll do here is we will actually do the complement. If we find out the probability of choosing blue or M, we can find the complement of that. Okay, complement, you notice the complement, here's the little prime symbol right here. Okay, this prime symbol means we want the complement. To do the complement, we're going to do 1 minus choosing blue or M. So a blue letter is 3. There are 3 blue letters over 11 plus M's. There are 2 of them, 2/11. And are there any blue M's? Yep, there is. There's 1 of them. So we subtract 1/11, and that gives us 1 minus 4/11 is 7/11. So the probability of not choosing a blue or M is 7/11. 7/11ths. All right, folks. That's the end of the video. Okay, another way to, I just want to do one more thing with you all to understand how the Venn diagram works. A lot of times students have a hard time with Venn diagrams. So I wanted to go over how to get this Venn diagram that I just showed you by doing the following. Okay, are you ready? What we're going to do is we're going to take the previous question, we're going to take that mathematics and put that on a separate page. So we're going to put that on the separate page, and we're going to take these points, these letters, and put them into a Venn diagram. So you can understand Venn diagram doesn't necessarily have circles that coincide, but specifically we're going to put everything into a set. Now we want to choose blue or M. So the blue or M, the M's have their own set from the word mathematics. So I took all the M's. So I took this M with this M and this M over here with this M, and I put them into the circle. So that's exactly what I did. I also took the consonants, blue or M. So I took the blue letters, and the blue letters have their own circle. Okay, and that's this, T, I, and M. So all the blue letters were T, I, and M, and they made their own circle. Now, the combination of the two was when it was blue and a M. That was the middle. And so when we calculated it by saying, okay, 2 in this circle over 11 plus 3 over 11 and minus the 1 that was doubled up. So that's how we were able to calculate the probability using a Venn diagram. All right, folks, that's the end of the video. Have a numerical day.